Want to know how to make your Kamal-powered review apps deploy faster and show your team where they can access it? Let's do those things in this video. Throughout this series, we've gone through the entire process of setting up a review application workflow for our web apps using Kamal, from setting up our cloud infrastructure to getting our application fully deployed and ready for testing. The review app process works great and is stable enough to put to use on any web project hosted on GitHub. Still, we can tweak a few things to make the workflow more efficient and easier to manage. This video will go through 2 additional nice-to-have modifications that'll make updates to review apps much faster and help others reach it with a single click. When setting up this process, you might notice that when we perform the deployment with Kamal, it rebuilds the Docker image from scratch every time we update a pull request. By default, Docker caches the build on disk using its own internal cache, which speeds up future builds by skipping any layers that don't need to run again until it runs into a layer that does. This kind of caching works great when building Docker images on your local system, but since we're building the app on a GitHub Actions self-hosted runner, we lose that build cache every time we use Kamal for deployments. Not having the build cached leads to slowed updates to our review apps, especially on GitHub Actions, since their default runners are much weaker than a typical developer system. In the example used in this series, it takes over 5 minutes just to build the TeamMap app when updating the pull requests. 5 minutes doesn't seem like much, but this time adds up, especially if you're trying to rapidly test and iterate on a branch. Instead of having the image rebuild every time, even if there's a minor change to the codebase, we should find a way to cache the build externally so we can reuse it and speed up the process. Fortunately, Kamal has support for setting up Docker's cache storage backend, which we can use to cache our builds. To get it working, we'll need to set up a few new settings in the Kamal configuration file in our repo. I'll set up caching for the review destination only in this example, so I'll open up the config deploy.review.yaml file that we set up previously in this series. This file contains the configuration for the review destination, so I'll add a new section. It could be anywhere, so I'll just add it under the proxy here. And I'll add a new top-level key called builder. This key lets us configure how to build the Docker image when deploying with Kamal. You can use this key to control different settings to pass over to Docker during the build process of your application's image. The configuration we're interested in relates to caching, which we can set under the builder key using the cache setting. And this setting uses a few parameters for configuring how we want the caching to work. First, we need to specify the type of cache that we'll use. This setting tells Kamal which storage backend to use. Docker supports multiple caching mechanisms, but as of Kamal 2.6, it only accepts 2 kinds here. It could be either a registry, which builds and pushes the image and the cached build to a Docker registry, and GHA, which is more convenient for our use case since it uses the GitHub Actions. The GHA cache type will save the build cache, including the Docker image layers, to the integrated caching service that GitHub Actions provides, so we don't need to worry about setting up a registry or any other storage backend. Besides setting the type, we can also set additional options to use for the caching process, which are set up as comma-separated key value pairs, separated by the equal sign. The GHA cache has a few different options to use, most of which you likely won't need. However, one option that you should consider setting up is the mode option to specify what to cache. There are 2 options for setting the mode. The min or the minimum cache mode only caches exported layers, which are essentially the layers contained in the final build and won't include any layers from the intermediate stages. This mode reduces how much storage is used for caching and makes the caching step quicker, but depending on your Docker builds, you'll probably have fewer cache hits, which kind of defeats the purpose of caching. The max cache mode, or maximum cache mode, on the other hand, caches every single layer in the process, including all layers from intermediate build stages. This mode gives you a much better chance of having cache hits during subsequent builds, with the trade-off being that the resulting cache will be much larger. Depending on how you set up your Docker file, one mode can work better than the other when it comes to caching. In my experience though, the typical Docker build for a Rails app benefits from having all of its layers cached, so I'll set the mode to max here for Kamal. If you're using Kamal to deploy other types of web applications, it's worth experimenting with both modes to see what works best in your use case. As a side note, it's worth noting that the GitHub Actions cache service has a 10 gigabyte storage limit. So when it exceeds this limit, your old caches will get evicted from the service, and it could lead to slower builds depending on your Docker configuration. So make sure to keep your Docker images as small as possible to reduce the chance of this happening. With this builder configuration set up in Kamal, it'll handle setting up the appropriate flags during the Docker build process. However, this configuration alone won't get caching working on GitHub Actions. We still need to add a few more steps to our GitHub Actions workflow to get things working correctly. First, we'll need to update the self-hosted runner to use the correct build driver for Docker. Kamal uses the default Docker build driver during the build process, which doesn't support exporting the cache on the GHA storage backend that we set up in the Kamal configuration. Thankfully, switching the driver on a GitHub Actions workflow is pretty straightforward. The Docker team has an action called docker/setupbuildxaction that handles this automatically for us, so we'll add it to the deploy job we set up earlier in this series. We'll need to set this up before triggering the Kamal deploy so it's ready to use at that stage. So I'll just create a new step just after checking out the code here in the repository. And I'll create a new step here with the name of set up Docker build driver. And it uses the docker/setupbuildx action. And as of this recording, the latest version is version 3, so I'll set it up here. This step allows us to configure the Docker builder on the runner. By default, it uses the Docker container build driver, which does allow cache exports to the GitHub Actions cache service, so we don't need to do any additional configuration to this step here. Using this action configures Docker to export the cache for our builds, but the GHA cache storage configuration that we set up in Kamal needs to know the remote URL of the service to retrieve and set the cache, and it also needs authentication to allow the workflow to connect to the service. Again, we're lucky that an action exists to automatically handle these for us. So let's set it up here as a new step and call it expose GitHub runtime for caching. And this will use an action called crazy max/gh action -github-runtime, and this one is also version 3 as of this recording, so we'll set the version here. This new action exposes a few environment variables that the GHA storage backend can use for authentication and to know where to send the cache. Those environment variables are the actions runtime token, which contains the authentication token that GHA uses to access the GitHub Actions cache service, and actions cache URL, which is the URL pointing to the cache service for the current repository. These environment variables automatically become available on the runner without any additional configuration. With these new steps added, our cache is in place and ready to work. But in some cases, adding this additional configuration to set up caching with Kamal can lead to timeouts during the setup or deploy process when the Docker build isn't cached. Kamal opens an SSH connection to the server, which remains open during the build process. If it takes too long, the connection drops with a timeout error and the workflow will fail. In the example application for this series, the time overhead added by the Docker build caching causes these timeouts to occur when running the workflow for the first time in a new pull request. While I'm not exactly sure why this is happening, my guess is that it's probably due to how SSH works on the GitHub Actions self-hosted runner to prevent any stuck connections from halting a workflow. As a workaround, I'll add an extra step just before running Kamal setup or deploy to build and cache the image first without logging into the review app server through SSH and push it to the local image store on the runner. This way, the Kamal setup or deploy step can use the cache and avoid the timeout. So just before this step, I'll add a new one and I'll call it build and push Docker image, and I'll run a command here, which is bundle exec Kamal build push. So this new step uses the Kamal build push command to use Kamal to build and push the Docker image as it specifies in the command. This step only performs the build and the push process without doing everything else that Kamal setup or Kamal deploy does. In addition to this command, I'll add a flag called output, and I'll set the value of this to Docker to push the image to the local storage instead of pushing it to a container registry, which is the default for a Kamal build push. We only need to run this command so that it builds and caches the image, so we don't have to push it to any registry for the time being. We'll also need to set the destination, which is with the D flag, and set the review value for later deployment, and also to use the new caching configuration that we just set up earlier in this video. With this additional step, GitHub Actions will build the application's Docker image before moving on to the Kamal setup or deploy step, which will only take a couple of seconds since the image will be cached beforehand, and it'll avoid any issues with timeouts that you might be experiencing. As a side note, you might not need this workaround if your Docker image builds are fast enough. This is only needed in cases where the Kamal setup or deploy steps cause timeouts on the GitHub Actions runner, which is what's happening with this particular example. If your Docker builds are fast enough and you don't get any timeouts, you really don't need to do this, and you could just use Kamal deploy or Kamal setup as normal. So now let's test it out and see it in action. When opening a new pull request in the repository and going through the provision and deploy workflow that we already have set up for this application, Kamal performs the full build for the Docker image as seen earlier, but it does it in a separate step. And as you can see, it takes 6 minutes and 17 seconds, so a little over 6 minutes to do just the build. And the setup and deploy step, because it's doing the initial setup and the bootstrapping of installing Docker and setting up Kamal proxy and the rest of the things that it does during the setup, takes a little over 1 minute, but it avoids the timeout that I was hitting earlier when I was trying to get this up and running. So this is taking just about the same amount of time as before. However, if we go to the cache section for our repository, we'll see a lot of new entries here. Each of these entries is one of the cache layers from the build, along with some build metadata since we set the mode to max in the Kamal configuration to set up the caching. If we had set the mode to the default min setting, we'd have a lot fewer items here in the cache, but as mentioned earlier, you would have less chances of getting cache hits, so you'll just have a lot of cached entries here, and it'll increase the probability of getting a cache hit. So now that we have our cache working, let's update the branch and push those changes to the pull request to trigger the workflow again. Once the workflow runs again and we see the time spent during the build, we'll see that the build this time went from a little over 6 minutes to under a minute, so 35 seconds now. And if we open the logs here, we'll see that most of the layers were cached and don't require any additional building. So it's pulling the Docker image layers from the cache and it doesn't have to go through the whole process again. So the overall time for our build is drastically reduced. With just a handful of changes to Kamal and GitHub Actions, we now sped up our Kamal deploys by about 90% after that initial build. This improvement really reduces the amount of time spent waiting for the review app to redeploy after an update. Now that we sped up redeployments to our review apps, one last thing that I wanted to handle in this process is to make it easy for people to know where the review app is. In part 4 of this series, I modified this workflow to generate a unique URL for each review app. The URL is based on the pull request number to make it easy to access, but we can make this easier by having GitHub Actions submit a comment after a successful deployment showing where others can find the app. We can handle this directly in our GitHub Actions workflow by using the github-script action. This action sets up everything we need to access the GitHub REST API, including authentication, the workflow's context, and references to different libraries for interacting with the runner. The GitHub API has an endpoint for creating issue comments, which we can use here since a pull request is technically an issue on GitHub system. Let's begin setting up this action in our review app workflow by adding a new step at the end after we set up or deploy our app, since we want this step to take place after the Kamal process wraps up. I'll add a new step here, and I'll call it leave a comment. This step will use an action, so we'll use the uses keyword, and it'll use the actions slash GitHub dash script action. And as of this recording, the latest version is version 7, so we'll set that here. And this action requires one parameter, which we can set with the with key. And the parameter is called script. And this parameter takes an asynchronous JavaScript function call, which we can use to make API requests to GitHub. The action itself uses the OctoKit REST JavaScript library under the hood, and it's pre-authenticated using the default GitHub token environment variable that GitHub Actions creates on every run. So all we need to do is specify our function call to the API using OctoKit in this parameter. This will be a multi-line script, so I'll start it with the pipe. And because this parameter expects an asynchronous JavaScript function, we'll have to use the await keyword. And the OctoKit client is already set up in this action, but it's set up as GitHub, not OctoKit as the documentation suggests. So make sure to use GitHub here. And with the client object, we can set up the request for creating a new issue comment, and it'll be under rest.issues, and the function name will be called create comment. The create comment function requires 4 parameters, which we'll set here. And the first parameter is owner, and this is the owner of the repository where we're making the API request. The workflows context contains this information, and we have access to the context using the context keyword here, and it'll be under repo.owner. The second parameter we'll have here is the repo, and this is the full name of the GitHub repository for the request. Again, this information is in the workflows context, so it'll be under context.repo.repo. The next parameter we'll set here is the issue number, and this is the number of the issue or the pull request where the comment will get posted. As mentioned, GitHub considers pull requests as an issue, so the name may seem confusing, but setting the pull request number here is valid. We already have this information available in an environment variable as we've used in previous videos, but we also have it in the workflows context, which is easier to use. So it's under context.issue.number. Finally, the last parameter is body, which is the content of the comment's body. We can use plain text or markdown here, but for simplicity, we'll use plain text. I'll open up this string using backticks because I'll interpolate a value later. And let's just set a message something like your review app can be found at, and we want to interpolate the value here. So it'll be HTTPS and the value of our URL, which we already have set up previously in this video series under the review app host environment variable, which will be review dash and the pull request number .teamyap.app. The GitHub script action has access to the runner's environment variables using process.env and the name of the environment variable that we want to access, which in this case is review app host. So with this, our workflow will create a new comment in the pull request using the GitHub Actions bot user, since we're authenticating the client using the default GitHub token. When we update the pull request made for this example, we can see a new comment appear showing the URL for this review app to make it very convenient to know exactly where the review app is. So creating a new comment is working great, but we have a small issue. If this pull request is updated after it has this comment pointing to the review app, the GitHub Actions workflow will create another comment with the same content every single time. And we really don't want that because we should only have this comment created once. So let's update the workflow to do that. We'll want to check if there are any existing comments for the pull request to determine whether we should create one or not. There are a couple ways of doing this, like checking the body of all comments to see if they contain the URL for the review app. But for this example, I'm going to assume that the GitHub Actions bot user only creates this specific comment in the entire pull request during its lifetime. So I'll update the script to check if there are any comments coming from this user. If there isn't one, then we'll proceed and create the comment, but if there is one, we'll just skip the API request. So at the beginning of the script, I'll make a request to the GitHub REST API as I did before using await github.rest.issues. And this time I'm going to use the list comments function, which is a function that retrieves all the comments for a given issue or pull request. This function requires 3 parameters, which are 3 of the same ones that we use for the create comment, which is owner, repo, and issue body. So we already have that information here, so I'll just copy and paste it, and we'll have it here. The results for this API request will come wrapped in a data object, and it'll be under the comments key. So I'll create a new constant and store that destructured value, which is under data, and it'll be under comments, and we'll assign that. So the result of this API call will be stored under the comments variable, which we want to check after this. The comments variable will contain an array of all the comments in this specific pull request. Next, I want to see if there are any objects inside comments that matches the GitHub Actions bot username. So I'll create a new constant here and call it existing comment. And for this value, I'm going to use the comments variable that we set up. And I want to iterate through each of these comments and check if the user exists. So for that, we can use the sum method. And the sum method basically accepts a function, and if the function specified inside here returns true for any of the elements in the array, which in this case is the array inside the comments variable, then this will return true and it'll assign it to existing comment. If none of the elements inside comments returns true for our check, then the result is going to be false for existing comment. So the function I'll set for the sum method is pretty simple. So it'll take each item, which I'll assign to comment, and I'll iterate through each one of them and check if the user matches the GitHub Actions bot user. So each one of these comments will have an object inside called user, and inside user we'll have the login, which actually returns the official account name for the user leaving the comment. To check the GitHub Actions bot user, we can check if this login equals GitHub Actions and bot inside these square brackets, which looks a little bit strange, but it's actually the official username of the GitHub Actions bot user, so we can use it to match any comments here. So now that we know if the GitHub Actions bot has created a comment in this pull request, we can use this as a conditional check for creating the comment if necessary. So here I'll add a conditional check using if, and in this case we'll check if existing comment does not exist. So if the GitHub Actions bot user has not created a comment, existing comment should be false. So basically we're checking here if this is false. So if it is, we'll make the API request as we did earlier. And if existing comment were to be true, which in this case it'll be when we update this, it won't create the comment, it'll just skip this API call. So in that case, we won't get any duplicates. With this modification, we can now update the pull request as many times as we want, but it'll only create the comment with the review app URL only once. So let's see if that works. As we can see, I pushed the new commit to this pull request, and we still only have one comment. So our update is actually checking correctly that the GitHub Actions bot user has already posted a comment. The updates made in this video are small and optional for our review app workflow, but have a huge impact on team productivity. Developers and testers will enjoy quicker iterations by speeding up build times for updates and having a link to the temporary environment directly on the pull request. The result of this is faster QA and shipping your app quicker than ever. From here, you can continue expanding this process and make it fit your development lifecycle better. Leave a comment or reach out to me and let me know if this series helped you out and how you've added and improved upon the basics that I demonstrated in the past 6 videos. I hope that it serves you and your team well to build and deliver high-quality apps in record time. And if you want to continue improving your software development processes, make sure to subscribe to this channel to watch more videos that help teams ship their code confidently, from development to testing to deployment. You can also check my website for a written version of this video, along with more in-depth articles covering Rails, testing, DevOps, and other software engineering topics. Thanks for watching, and I'll see you in the next video.